Hello, Maurieo! This is just a quick little video to show you a few things that might be helpful if you want to do a plot of a survey from your field notes where you don't say have survey software available, and so you want to get a bit of an idea of how things look at to a reasonable sort of scale. So let's just turn this this title layers off to get rid of the titles there, and let's make a start. Now the first thing you need to do is to type in your units, or sort out your units, which brings up the units palette here, and you can see here that set on decimal, 3 decimal places, and in meters. Surveys work in meters generally. Degrees, minutes and seconds, precision to the nearest second, measuring them clockwise and of course clockwise from north. So that means that we're going to get all our bearings set up going the right way. And then the next thing we need to do is to, and I'm going to just look at recent inputs to see which ones I've used, and it seems that the one I wanted to check on is not there, so I'll just escape out of there, and I think it's called DDP type. DDP type, and that brings up this point style palette here. So that was DDP type. At the moment the point style there is set to this little point, which is very faint, difficult to see. Just going to set it here to the cross like so. Just makes things a little bit easier to work with. Now what I'm going to do is, in New Zealand we sort of work in total coordinates quite a lot, and a lot of surveyors do, and the system that we work in typically has an origin of 800,000 and 400,000 currently. So when we're working on little projects on an assumed origin, I'd sort of maybe stick with a similar sort of regime, and I like to call my coordinates or assumed coordinates 7,000 and north and 3,000 east. So in this little thing here, I'm just going to create a little point, which is the assumed origin of this assumed job that we're working on. So we just type in PO for point, and then we can actually put in our coordinates. Now AutoCAD works in an easting first situation rather than the northing first, so I'm going to key in an easting of 3,000 comma 7,000, and I'm going to put in a height, although it's probably not necessary, of 0, and it's quite important that you keep it at 0, because when you're doing measuring in AutoCAD measures in 3D, so if you have points on different heights, you're going to get the difference. You're going to get a slope distance rather than a sort of horizontal distance. So you must make sure that when you're measuring between points, that you're measuring between points with the same height. So that's created that point, and as you can see spectacularly, nothing has happened. But if we are to go Z for zoom and E for extents, there's our little point up there, and then if we click on our point, look over here in properties, 3,000, 7,000. Okay, so we've got a starting point. Now we possibly need to put some vectors in, some bearings and distances. So we just can use our line tool here, or just type L for line and specify the first point, and we just click on there. Now that's highlighting there as a node. Just remember that you've got to turn on here your object snap, right click settings, and these are all these little ticked boxes. We've got endpoints, square endpoints, triangular midpoints, circular centers of circles, and little circle with a cross for nodes, intersection of 2 here, perpendiculars. So these are all the different points that they'll recognize on the screen here and snap to those points. Okay, so we want to draw a line. So there's the first point there, and let's put in a line, and we've got specific bearings. Now to put in the specific bearing, what we have to do is hold down the shift key and hit this little one here to give us the greater than symbol, and then we'll put in our bearing: 45 degrees, 45 minutes, 45 seconds. This is one I'm going to use here. Typically that's one I use, and we push enter, making sure that in the command line we get the angle override. So that's where the angle override is. Remember that that'll be 45 degrees, 45 up there, but down here would be 180 different, 225, 45, same line, 180 degrees different direction. So let's look at our let's put that in as 100 meters, and oh, lo and behold, it's way down here. So that's how it was still in our line command. We got this bloody great cross in the middle of things, so let's just escape from there, and we just type RE, and that regenerates the drawing, just making the cross to a more manageable size. And just clicking on our line here, looking in the properties symbol, and the properties thing over here, got a start X of 3,000, 7,000 and 0 height. Very important. If the heights are different, the distance that AutoCAD reports will not be a horizontal distance, it will be a slope distance. These are the coordinates of our endpoint, so we could check our Travis sheet coordinations, and then this is the distance and the angles. So another sort of thing you can do is just use the point command, PO, enter, and just create a little point here, which enables us to click on there and individually look at the coordinates for that. So let's put another line in here, for instance, and we'll go so if that one was 45, out here we'll go 135 degrees, 45 minutes, 45 seconds. Oops, now you can see there that there was no angle override came in here, so I've sort of got things wrong, or forgot to put the greater than. So there, 135 degrees, 45 minutes, 45 seconds. There's our angle override. We're away. Let's go 100 for our distance there, and there's that point there, and then we'll come down here. So that'll be 225 degrees. Oops, I forgot my little, it's quite a 225 degrees, 45 minutes, 45 seconds. Yep, there's the angle override there in the command line, 100, enter. Alright, now let's for instance, let's just say that we come back here. I just want to show this idea of misclose. So let's say, for instance, on this particular instance, the bearing that we get back there might be, for instance, 315. Oops, 315 degrees, 45 minutes, 45 seconds, because we should have closed our bearings. And there's our angle override, and that should be, but let's say for measurement's sake it became 99.98 rather than 100, which should give us a little bit of a misclose in there. So we'll just go in there and have a look. So you would expect that we'll get a little bit of, it doesn't quite come back to the thing there, and that of course would be our misclose. So if we were to go into there and just draw a line from there, I'll just I'll just draw a line from there to there, from there back to there, and if we click on that line, highlight that line, you can see that's our misclose, 0.02, and on that angle, which you would expect from the way that I've put those coordinates in there. Now AutoCAD can't adjust those out. We would adjust those out on the Travis sheet, and we would adjust them out so that any adjustment went into the coordinates. So in AutoCAD, what we can do is we can just accept that little error is there, and we just join back to the start for our Travis. If you did want to have the adjustment represented in your traverse here, what you would have to do is to individually key in the coordinates of each of these points. So I'll just put little crosses there just to make that into like so, and like so. So there you go. There's your your traverse you put in there. The misclose is all in one spot, it's not distributed around. If you want to distribute the misclose around, you would need to key in the final points. Now, just one other quick thing before I go. Obviously, plotting this out, there's going to be some things, but we'll have a look at that in another video. So let's just put in a couple of pegging ties here. So let's put in a line here from there, and let's just say that's going to be at 85 degrees. Let's just see if we just put 85 degrees. Yeah, that's at 85 degrees, and that's just going to go for 20 meters, and that'll give us a little point there. And let's just come down here at this one here, and we'll put another one in here. And now that was 85, so let's go at 265 degrees, and again we've got our overload in there for 20 meters. Okay, so these are two little points that we've picked up with pegging ties. Let's just PO them and make them little points. PO enter, and so this is showing you that you could key in points. Now, how you might want to check the bearing and distance between them. So I'll just pop up to here and just change the color a little bit. Oh, here's the color here. I'll get to the right one. Change the little color bit, and I'm just going to draw a line from here to there. Okay, and let's just click on that, and then we can check our bearing and distance. So 196 degrees. Just remember that AutoCAD tends to leave out the leading zeros, so 196.0359 and a distance of 150.784. Just pays to check in here that the heights are the same. If you sort of start fiddling around with the heights and that, you can cause a few little problems. So there's a few little tips and things for putting in bearings and distances and coordinates and what have you into AutoCAD to get you started, so you can have a look and see what your job's looking like, and you can also just do a few little checks and things on some of your calculations. So I hope that works for you. If you've got any more questions or things you want to know, just drop me an email or send me a note, and I'll have a bit of a look and see if I can come up with a video that might be able to help you. All good. Cheers.